Take 4. Here we are going to look at another 3-wire circuit, but in this case we will have an open fuse instead of an open neutral. And our open fuse will be on L2. We should be able to calculate the voltage drop across each of the loads and of course the voltage across the open fuse. As before, we can use R equals E squared over P, or two-step method, I equals P over E, then solve for resistance for each of the loads based on their rated voltage. Using 120 up here, we get 16 and 24 for R1 and R2, 36 ohms each for R3 and 4, they are balanced, and 12 ohms here for R5. Now we need to identify which loads are in series and parallel by marking the current direction from L1 to neutral. Now these loads are equal, so equal current would flow down each. But we can see here that our 36 ohms that are in parallel with each other are in series with the 12 ohm resistor. The original 120 volt loads up here will remain unaffected. So now we'll need to find the equivalent resistance of the parallel 36 ohms and add that to the 12 ohm resistor to get a total for this branch. We could use product over sum or the reciprocal method, or since these resistors are equal, divide by the number of equal resistors. 36 divided by 2 gives us 18. And then we add that to 12 ohms to give us 30 for this branch. Now we can calculate the current of the branch using 120 volts and our equivalent for R3, 4, and 5. And then we can use that current to figure out our voltage drops across each of the loads. So we find our current, 120 divided by 30 will give us 4 amps. So 4 amps will come this direction, split equally, because these loads are balanced, and then come out the bottom, back the other way, and we'll have 4 amps here. We can figure out our voltage drop across this resistor, 48 volts. Now we could subtract 120 from 48 volts to get this, or we could prove that by multiplying 4 amps to 18 to get 72 volts here. In the end, this should add up to 120. Now we can calculate the voltage across the open fuse. We have a potential of 120 to neutral on the L1 side, or the unblown side. And we have a potential of 48 volts to ground, to neutral, on this side of the fuse. We've already lost 72 volts here, so 48 plus 120 will give us 168 volts across the open fuse. To check, we can calculate the voltage from L1 to L2 and vice versa, and this should add up to 240. And we can see that it does. 168 plus 72 equals 240. The voltage drops and currents through R1 and R2 will not change, but I've added them in just for reference. The end.